At Shine Technologies, our long-term mission is to develop an affordable, sustainable solution for nuclear fusion energy. To get there, we are working through a 4-phase pathway that not only advances our fusion technology, but also makes our world safer, cleaner, and healthier each step of the way. Let's take a closer look at our 4 phases.
The 4-phase sort of business strategy came out of looking for the nexus of really 3 things at each phase. And the 3 things really had to consist of essentially things that I thought were reasonable advances in technology. So going from one phase to the next needed to have what I considered to be a reasonable jump in technology, something that was where you could see a line of sight from where you were today to where you wanted to go in the next phase. Then that had to intersect with where there was a clear and demonstrable social and market need today, such that we could quantify where the business was going and show that it was worth it. It's essentially show that it was worth going after that phase. And then ultimately, the third characteristic was that it had to advance us towards our ultimate goal of producing nuclear fusion energy.
Phase 1 is essentially taking fusion technology, machines that produce neutrons, and do useful things with them. Things like taking pictures of the insides of aircraft parts, for example. Phase 2 is taking that same concept and ramping it up a level to produce medical isotopes so we can help cure cancer and detect heart problems and things like that. Phase 3 is then taking that same concept and ramping it up another notch to kind of turbocharge it and get into solving our nuclear waste problem. So taking sort of the leftovers from the nuclear fission fuel cycle and turning it into the things that you can do good things with, like make computer chips out of them in the future and things like that. And then phase 4 is really going to that sort of final level, which is yet another sort of jump up in sort of that core technology, the neutron generator fusion machine at the heart of it, and make so much extra energy that you're actually able to turn that energy right to electricity and power up our lights and laptops and everything else.
So in phase 1, we've built a custom neutron generator, which is a particle accelerator that sends a beam into a target, and that interaction produces neutrons. And then we use those neutrons to take a radiograph or an image. I like to tell people it's really similar to an X-ray, where you're using a gamma in that case to make a radiograph, and in our case we use a neutron, which interacts with materials differently than X-rays do, so you can see different things and image different things with better resolution.
In phase 2, Shine has another great opportunity for medical isotopes that can provide a lot of value to the world. We're producing a product today called lutetium-177. And lutetium-177 partners with a drug to treat late-stage cancers. The drug finds the cancer and labels it, and the isotope damages or even kills the cancers that are around it. A great example is prostate cancer. Novartis was approved by the FDA for a drug that treats late-stage prostate cancer. This drug partners with lutetium-177, which we will make, to treat those cancers and allow people to live a longer life. There are over 25 different cancers that are in drug trials today, and they all partner with lutetium to provide value to patients. So we're very proud to be part of the story of helping treat cancers.
Phase 3 is inspirational because we further go after how do we reduce the volume of waste, which makes fusion energy or nuclear technologies really plausible for the future, and mindful of current climate change and additional energy deficiencies that we see in the future. And phase 4 is what it's all about. Phase 4 really is about creating an abundant source of energy that's clean, that's plentiful for people across the world.
You can actually use this technology to create clean nuclear energy, which is called nuclear fusion. Instead of current nuclear energy is splitting up uranium into pieces, which is creating a lot of energy, but also comes with creation of waste. Nuclear fusion is clean. You basically do not have the problem as with nuclear energy caused by fission of uranium. That means that long term, on a global scale, we will contribute to creating a solution for clean energy that is widely available.
Well, I think the work we're doing is really important today for a couple of reasons. I mean, if you look at phases 1 and 2, the nuclear reactors that historically supply neutrons for non-destructive testing, which plays a vitally important safety role in the production of modern aircraft. And you look at phase 2 with medical isotope production, again being produced in very old nuclear reactors. These reactors are going offline. The largest reactor for isotope production shut down in 2016, and the result of that has been periodic shortages of isotopes, causing patients to not be able to get the right medical tests or even therapies that they need. We're expecting a number of these reactors to shut down in the coming decade as well, a number of the remaining reactors. And that's going to really limit isotope production. So you're going to have patients in a situation where they just can't get the best tools needed to diagnose and treat their disease, and that's unacceptable. And we don't want that to happen. And nuclear fusion offers a solution that's immediate, that can be applied to make sure patients get what they need. And we can do it with much lower cost and much cleaner environmental impact than you would have associated with fission reactors. So that's like super urgent, and shortages are ongoing today, so we're really focused on that. I think as you look at phases 3 and 4, it's about climate change. The ability to remediate nuclear waste, really, it's my hope that helps nuclear fission power become a bigger part of the energy mix. And nuclear fission does not generate greenhouse gases. It's awesome baseload power, highly available, and very, very reliable. I see fusion as the first time when humans will really have access to nuclear energy that's abundant. This is a turning point in human history and human evolution when our species will have massively increased access to energy. And it's very much, to me, akin to when humans first discovered how to control fire like 1 million years ago. So we're at that turning point, and so while it can play a role in climate emissions, even more exciting for me is what it's going to do for us over the next 1 million years, not just what it's going to do for us over the next couple decades.